Hi everyone, welcome to my channel, Maths Made Easy with Terry in 10 minutes. So we're going to talk about position and location vectors. Um, in the previous video, I've talked about the difference between a position and a location vector. So it's very important that you've watched the previous video before coming here, because remember I said I'm going to be laying the background. So the previous video will be the background for the next one. All right. So make sure you've done that. And before I proceed, don't forget to like, share, and subscribe. If you've not clicked the notification bell, I don't know what you're waiting for. Please do so that when I post new videos, you'll be the first person to know. All right, so if, for instance, we have two vectors, A and B, for instance, and they are position vectors, and you are not told to find a vector AB, how do you go about it? All right. So what I'm going to do, I'm going to try to dramatize it. So because remember vectors, I told you for vectors, when you have, so we have a location vector A, uh, we have a location vector A, all right, and we have another location vector B, and we are now told to find the vector AB. Is that making sense? How do you go it? So I'm moving from A to B. So I've talked about this in the first part. So how do you do it? So what I always do, I always try as much as possible to try to draw pictures of it so that you can picture it. So you're moving from A to B. So to be an easy way for you to solve this. Also, I'm going to try to derive a simple formula on how to find vectors like A, B, B, C, and the rest of it. But before I go there, I'm going to try to show you how I got to that formula so you don't need to cram it, all right? So let's go. So let's say we have so we talked about that if A and B are position vectors, right? If A and B have position vectors, so have position vectors A and B respectively. Okay, so we can now write AB, right? Can be written in terms of A and B. All right, so what do you do? So you notice it there. All right, so let us draw this. So we have position A. So it's a position vector, so it's being referred to a fixed point. So let's assume that the fixed point here is an origin. Okay, let's start from there. So we have position vector A, or you can put the arrow A here. Okay, so the position vector is this. Okay. And we have another position vector B. Okay. We have another position vector here, B. And we're told the position vector is what? B. All right. Now, the question here is that they want us to find the vector A, B. So that means we're finding the vector A, B. So that means, remember I told you that vector AB means that you need to start from vector A and get to vector B. Is that making sense? Now, what I always tell students, so if for instance, I want to move, let's assume this is my house, okay? I always give this analogy. So let's assume this is my house here. So I have this beautiful home here, all right? Okay? And I want to go to, let's say, a shopping mall, okay? Let's call a different shopping mall somewhere down the street. So, okay, somewhere a little bit far. So I want to go to the shopping mall here, all right? Let's assume that's the shopping mall. Now, this is myself here, or a student, okay? I want to get there. Now, assuming, okay, you want to go there, maybe you can pick an Uber. Okay, or you pick a taxi, just pick a taxi. The taxi will take you all the way straight there. So it's very easy. Are you seeing it? You take a taxi, taxi takes you from your house all the way to the shopping mall. So that means this is my house here, okay? And this is the shopping mall, okay? The shop, okay? So take me all the way to the shop. Or maybe I can walk down to a bus stop. Then I now take the bus to the shopping mall. Or if, for instance, I have an helicopter, okay, I can take, let's make it interesting. Helicopter might be too stretch. Let's say, okay, I can decide to take, maybe I could walk down to a part in the road. Let's say I walk down to another different bus stop, okay? Then from the bus stop, I walk to a bus stop, a different bus stop. Then after walking to the bus stop, I now take a bus that now take me to another bus stop. Then I now walk down to the shop. So you can see in these three scenarios, the main thing is that I get to the shop. So that means either I take a taxi that just take me all the way down there, or I walk down to a bus stop, then I take a bus, or I walk to a bus stop that because I could not find a direct bus, so I walk to a bus stop, then take another bus and and walk down anywhere. So that means I can define moving from house to shop. So moving from the house, okay, to the shop. I can define it in three ways. Either I just take a taxi, or I walk. Take this a bit up. Or, right bit here. Good. Or I walk, then I take a bus, or I walk to a different bus. So let's call this bus A, and this is bus B, all right? So I take a different bus to bus B, then I walk down to the shop. Now, all these are the same way or different methods to get from the house to the shop. Now, that's the same thing you're going to apply to vectors as well. Now, in the vectors, I want to move from point A to point B so that I can get AB. So I have to move from point A to point B. So as you can see, the only way I can do this is that since I'm moving from point A to point B, so let's assume A is the house and B is the shop. So I want to move from the house to the shop. So what I can do, because I don't have any direct access like a taxi that can take me straight down, which is the red part, what I can do, I can decide, okay, I can decide to move from A, I can decide to move from A to O, right? I can decide to move from A to O, and I then move from O to what? B. Are you seeing it? Then I've gotten from A to B. Is this making sense? So that means in order for me to get to this point, I have to move from A to O, then O to B. That's the only way I can get from A to B. So, but if you look at OA, that was A, but I'm moving from A to O now in the opposite direction. So remember in the previous video, I said if you move in the opposite direction, the sign is going to change. So it's going to be minus A. Can you see? O to B is exactly the same thing as we have here, which is the same direction. It's going to become what? B. So that was the same thing as same thing as OB. All right. Now, we need to now, so this, in order to move from A to B, that means it's exactly the same thing as moving from O to A plus O to B. Are you seeing it? O to A plus O to B. So that means this is going to give you O to A is going to be minus A plus B. So that means I can now write this again, that AB will be equal to minus A plus B, or we can say this should be same thing as B minus A. All right? So let me just write this down because I know students do take notes so that I can write it now in a clear form for you to understand. So now, so to explain what I just said. So now to get, okay, from A to B, we have to go number one, from A to O, right? Then we'll now go from what? Then O to B. Okay, so that's exactly the diagram I drew there. So you have A to O. So we have A to O. And O to what? B. So A to O and O to B. All right. But we know because we're going in opposite direction, it's going to be minus, while this is going to remain B. And we're looking for what? A, B. So therefore, we can now say AO, because I'm moving from A to O, will be equal to minus what? OA, because remember, we are moving in the opposite sense or opposite direction, and that will be equal to what? Minus A. Then OB, which is equal to what? B, because it's still the same direction. All right? So now this is the formula I want you to keep in mind. All right? So from this now, like I said, we can now say AB now, if we're going from A to B. So AB is going to be equal to what? B minus A. All right? Now, this is it's a very important formula to keep in mind. So therefore, so if you want to convert between a position and located. So remember, OA and OB, these are position vectors, while AB is the located vector. So if you remember, I've talked about the difference between both of them, OA and OB. So these are both position vectors. Okay, we talked about this in the previous video when you have a position, but while AB is a what? A location vector. Okay, so I've talked about this in the previous videos when I talked about the types of vector. So to convert between a position and a location vector, okay, AB, so if for instance we're giving AB will be equal to B minus what? A. So if for instance in the exam you were given CA, all right, it's going to be equal to what? A minus C. If you are given DE, it's going to be what? E minus what? D. Are you seeing it? So regardless how you do it, it's going to be the second one minus the first. All right. So this is a very important formula for you to know. All right. So in order to convert, so even if I give you, let's say KH, and I say find the location vector for that, it's going to be H minus what? K. All right. So let's pick an example for this so that we can solve. So let's pick an example. Okay. So let's pick this example here. We're told if point A and B is given by A is 2, 4, minus 3, and B is minus 5, minus 2, and 1. So we're told to express as a column vector number 1, we express AB, and number 2, we're meant to express BA. All right, so we have these two questions. All right, so I know I've not talked about column vectors yet and the rest of it, but it's still exactly the same thing. I have a video for that down the line, but I just need to introduce this here quickly. All right, so if you have a vector, basically what it means is that if you have a vector, let's say you have a vector A, all right, you have it as the first one is the X component, the second one is the Y component, or you can have a vector A. If it's a 3 component, it's going to be X component, Y component, and Z component. Okay. So that means you can write this again as, you can write it like this, X and Y. This is as a column vector. Or you can write it like this, X, Y, and Z. Don't worry. We're going to talk about this later. Okay. We have a video for that. All right. But I just needed to introduce this position and location vector here because it's really, really important for us to understand this so that we can talk about the other concepts later. All right. So with that now, you can now say that the A now, I can write down the A as in this form. So we have it as 2, 4, and minus 3. Okay. Then we can write down the B as minus 5, minus 2, and 1. Are you seeing it? Good. So we're going to do that. Then the first question was AB, all right? So number 1, we're told to find AB. Okay. And remember I told you AB is going to become B minus what? B minus A, all right? So that is going to be the B, which is what? Minus 5, minus 2, 1, minus the A, which is going to be 2, 4, and minus 3. So basically, how you do this is that you subtract the S component together, the Y component together, the Z component together, and that's how you do it. So we're going to talk about that in addition and subtraction and magnitude very soon. All right. So what we're going to do now is going to become minus 5, minus 2. We have minus 2, minus 4. And we have 1 minus 3. Okay. And this is going to give us minus 2, minus 5 minus 2 will give you minus 7. Minus 2 minus 4 will give us minus 6. And 1 minus 3 is going to give you what? 4. All right. So therefore, we can now say the column A, B will be what? -7, -6, and what? 4. And that'll be the answer for that. The next one is BA, all right? So the next one is BA, that's number 2. Number 2 is BA. So now BA now is going to be what? A minus what? B. Are you seeing it? It's going to be A minus B. So let's go. It's going to be, what is the A? The A is 2, 4, minus 3, minus the B, which is going to be -5, -2, and what? And 1. So you see, it's going to be the second one minus the first one. So we're going to solve this now. Same way. We're going to have, it's going to become 2 minus -5, 4 minus -2, and we're going to have -3 minus 1. And that will give you, so we're going to have minus times minus will give you plus, and that will give you 7. Then you have 4 minus -2, and that will give you 6. And -3 minus 1 will give you -4. All right. So therefore, okay, we have BA will be equal to 7, 6, and what? -4. So if you notice, A, B, and BA are exactly the same thing, but you just notice that the signs are different. We'll talk about that later, all right? But that's how you find convert from position to a located vector. So it's very important. So if you have AB, it's B minus A. BA is A minus B. All right. So what I'm going to do is I'm going to give you an exercise to try. Try and solve it and put it in the comment section, or you can discuss with your friend and see if you get the same answer. Or if you could not get it and you're struggling, send me an email and I'll talk to you about it. Is that okay? So let's try this. I want you to try this, okay? So what I have here, that if P is equal to 4, 3, 2, and Q is equal to -2, -4, and 6. I want you to find PQ, and number 2, I want you to find QP. Okay. All right. So then I want to also try this one as well. So this is number 1. Okay. So I want to try another one. So this is number 1. Number 2, we're told if M is equal to -4 and 2, and N is equal to 5 and 8. We want you to find, take this up a bit. Okay, I want you to find NM. And number 2, we want you to find MN. And that is that for that. All right, so that is good. I want you to try that and see if you get the same answers. You can put your answer in the comment section, or you can discuss with a friend and see if you get the same thing. And that will bring me to the end for position and location vector. The next video we'll talk about will be vector midpoint. So it's important that you subscribe and click the notification bell. So when I upload the video on vector midpoint and how to find the midpoint of a vector, you'll be the first person to know. All right, see you soon. I'll see you in the next video. Have a nice day.